All right, so let's have a look at another function and see whether or not it is one-to-one and onto. So if a function goes from the integers to the integers, which means you put in an integer and you get out an integer, defined by f of x is equal to x squared, is it one-to-one and onto? So in order for this statement to be true, because we have an and, it must be that it must be both one-to-one and onto. If it is not one of these two, or if it is neither, the statement is going to be false. All right, so the first thing we're going to look at is to see whether or not this is one-to-one. So what does one-to-one mean? One-to-one down here, about our definition of one-to-one means if the output is the same, then the input must have also been the same. This means you cannot get the same output with two different inputs. So let's go ahead and think about this. So if we plug in, let's say, if we want to look at one-to-one and say we want to get 4 is equal to x squared, we're saying that if 4 is our two equal outputs, 4 can only be obtained with one input, right? So what can we say? Well, 4 equal to x squared means 4 can be equal to -2 squared or 2 squared. So clearly this is not true. Once again, if we were to write this out with our set notation, and this was going to be, apologies, this is going to be our two domains, and we plug in and we say, okay, for something to be one-to-one, it must be that when an arrow heads to it, and you want to trace it back, there's only going to be one person to trace it back to, in this case 4. But as we see here, 4 can be traced back to 2 separate inputs. So this is not one-to-one because we can have an input of 2 or an input of -2. So we already know the statement is going to be false because it doesn't meet the criteria of being one-to-one. But just for the heck of it, let's check to see whether or not it is onto. Okay, so let's have a look at some examples for our onto. So what does onto mean? Onto means that because we're looking at a domain of integers, we should be able to get any integer with a given integer x input. So this means when we make x squared equal to any integer, it should be possible for x to be an integer. So this means that if we want to get, let's say, 1 from x squared, this should be possible given an input of an integer x. And that's true because here x can be equal 1, which is in fact an integer. Fantastic. What about 0? Can we get 0 from this? And the answer is yes. So we're getting integers from integers. Is this possible? Yes, if we put an integer in. Sorry, I put that in incorrectly. 1 is an integer. 0 is an integer. Okay. What if we try something like -1? Can you get -1 by plugging in an integer into x squared? And the answer is going to be no. Why is that? Well, let's rearrange for x. What would x have to be here? Well, square rooting both sides, we would get the square root of -1 is equal to x, but the square root of -1 is not an integer. This is I. That's the complex plane. This is a complex number, not an integer. So what does that mean? Well, this means that it is not possible to get every integer from our function given an integer. So this means that it is also not onto. So we can say here that x must be equal to the square root of -1, which is not an integer. And another example you could think of if you didn't think of negative numbers is, of course, non-square numbers, right? You could think of, let's say, 3. How would you get 3 from x squared? Well, this would mean x would have to be equal to the square root of 3, which is also not an integer. So as you can see, we've already come up with 2 integers that you cannot get from an input of an integer. There does not exist an integer x for these solutions here. So we've shown that it is also not going to be onto. So let's go ahead and prove this statement. Okay, so in order to disprove the fact that this statement is true, in order to prove that it is false, we just need to write out the negation. And in fact, the negation of this question is just going to be that f is not one-to-one or onto. That's really what we have to prove, is that it is not one-to-one or onto. But that's going to be a little too simple because all you have to do is just prove, okay, you can either show the example of it not being 1 to 1, or you can just write down the example of it not being onto. I'm going to do both just so you can see what that would look like. So let's start. We can say that let f be a function defined by f from the integers to the integers. So f of x is equal to 2x for some x in the integers. Okay, next, let's start by proving it can't be 1 to 1. So how do we prove it's not 1 to 1? Well, this is our definition of 1 to 1, and you just have to write down the negation. This is a for all, so what's the negation of a for all? It's going to be there exist. There exist two integers such that their output is the same, but they themselves are not the same. So what are we going to say? We're going to say there exists a, b integers such that f of a is equal to f of b, but a does not equal to b. For example, let a equal to 2 and b equal to -2. What do we get? We say then f of a is going to equal to 2 times, oh sorry, not 2 times, it's going to equal to -2 squared, which is equal to 4, which is going to equal to 2 squared, which is going to equal to f of b. But 2, or let's write that down here, 2 does not equal to -2, so it is not 1 to 1. So there we go. We've proven that this function is not 1 to 1, so it cannot be both 1 to 1 and onto. Now let's go ahead and prove that it is not onto. So in order to prove that this function is not onto, we have to write out the negation of our onto definition. So we have to say that there exists an integer in our codomain such that there does not exist an integer in our domain such that f of x is equal to 2x. So let's go ahead and say that. There exists a y in our codomain such that there is no x integer for f of x to equal to 2x to equal to y if we want to be super explicit. So we can say, for example, now I just realized I forgot to write down, you should still write down let f be a function from z to z defined by this. You should still add that, and then you should add this statement. But anyways, let's go on and keep writing this proof down. So for example, let y equal to -1. Then f of x is equal to -1 is equal to x squared. So x must be equal to the square root of -1, which is not an integer. Or let me write that down maybe a little more explicitly. And square root of -1 is not an integer. So x is not an integer in f of x is equal to 2x. Or sorry, I keep writing 2x down. I mean to say x squared. In x squared here. So the function is not onto. There we go. We have disproven both scenarios, that it is not 1 to 1 and it is actually not onto. So there we go. We've proven that this is in fact neither.